Good morning to everyone. In this video, I want to be discuss about different data types in Verilog Programming Language. So here in this video, just I am giving an idea on the basic idea. If you want to be start a Verilog, if you are a beginner. Okay, in these videos, we are not going to be discuss briefly whatever means like with we are not discussing with the different examples. Just I am giving an idea. If you want to be explore the more things, then go with the materials, and you have to be read. Then you can find a lot of examples. Okay. In data types, actually, first we should know about the set of values. Means here in the Verilog value set. Actually, you have four types of values, four basic values. Those are 0, 1, X, and Z. So when you're writing your Verilog code, you have to be remember these four numbers: the logic 0, logic 1, unknown logic value, and high impedance state. Okay, so actually we know the logic 0 is for representing the false condition, and the logic 1 is representing the true condition. Okay, here the X we can use for unknown logic value, and the Z we are using for high impedance state. So just remember here already I told this in these videos I am not discussing briefly. Just I am giving an idea among those number of concepts. If you want to be start as soon as possible, as early of your Verilog programming. Okay. So next one of the important data type when you're writing a Verilog code is wire. Before going to be wire data type, I want to be introduce two types of data types. First one is the nets data type, and second one is the variable data types. The nets data types, one of the nest data type is mainly we can indicate it the wire data type, and a variable data type is another one that is we can indicate it with the register data type. So in wire data type, the wire is representing it is a physical connection. Okay, for example, if you want to be connect the breadboard with the help of breadboard, I want to be connect any circuit, we can use the wire. Here, see, the wire cannot hold any value. Same here also in our Verilog wire data type. Here we can't hold any value. It is a read and not only assigned in a function or a block. So it can be read any value and it cannot hold any value. For example, I can declare a value like wire space a. So it is a representation of I am representing a is a is it's a like any input otherwise output. Okay, so it is a value, but it is not storing. It's not. It's a connection only. Okay, so I can represent the y data type with a different format also, that is y 3 to 0, and with the with a value of n0 means n naught. Here the four connections we have wire. Here it is only one connection. Wire A it means it is only one connection. Wire 3 is to 0 means it is we have four connections 3 to 0. So we have to be represent like n0 to n0 0. So this is the means like now just remember here what is the wire, and when we are implementing the code, then you can easily understand and how the use of wire data type. So next one is the register data type. The register data type is I told you is a very it's a variable data type. It's one of the means keyword we can use rez register. Rez is a keyword to represent the data type. It can hold the value from one processor assignment to the next one. Okay, for example here res is a keyword to represent the register data type with space c. Means a c is a variable, and it can register means it's a variable. The value it can be stored like a single bit register. It's a c. Now 520 it is a 6-bit vector. It is a 6 bit vector means because I am representing 520. In 6 to 0 d comma it is a 7-bit variable, so here I am representing those values in this. And next one is the common data type. When you're writing the Verilog code, it is an integer. Already this same thing we should remember when we are implementing the code of C programming language, integer data type. But here the integer data type is a general purpose if representing the general purpose variables, and the default length and otherwise the size of the integer data type is 32 bits. Why I'm saying is a default size. See the example. I'm taking integer C. I'm declaring a C is a variable. It is an integer. It is taking a 32-bit integer. But while I'm assigning A is equal to 63, the 63 is an integer data type. So A is equal to 63. Assign is a keyword. Okay, A is equal to 63. 63 defaults to a 7-bit variable. So I want to be represent a 63-bit 63 number into a binary, then it can take the 7-bit variable. So here it is not 32-bit, so it is taking up to only 7 bits. So that's why here I am calling it is a default size data type. Next, the strings. In the Verilog code, we can represent the strings in the double quotations, same like other programming languages. That it can take each character, it can take a string at a 1 byte to be stored. Okay, for example, here hello world is there. The string with 12 characters, and x plus z is also string with 5 characters. And how are you feeling today is I am representing the string in 2 lines, so it is a invalid. You have to represent a string in a single line is possible in a Verilog code. Next, we have different operators like a C programming language. In Verilog also we have different operators like arithmetic operators, multiplication, division, addition, subtraction, modulus, division, unary, plus and minus, like that. Logical and logical are different types of operators we have. Here concatenation operation operator and condition operator. So just remember those operators when you're writing the code, it can be useful. And how to represent these type of operators when you're writing the code. Here for example, a is equal to b plus c means that is an arithmetic operator. Here we are using, here I am using the shift operator. In next one, a is equal to 1, it is a shift, it means left shift. So left shift I am doing by 5 positions of 1. So a is not equal to b is next, sorry, a is inverter of the b, means it is the negation of the b. So it is how many times do you want to do assign here the multiple drivers, so a negation. Okay, so here it is the symbol represent the bitwise negation. It is the symbol here the logical negation. Okay, just remember bitwise this is the bitwise negation, this is the logical negation. So these are the things I want to be introduced. Just different data types, like wire, one of the different data type we frequently are using when you are representing the code. And a register is one type of, and integer is also another type. And just remember that values are different value sets. Thank you.